Hello out there. Thanks for checking out this video on how to factor a quadratic that has a not equal to 1. In this video, we're going to look at 3 to 4 methods of factoring. The fourth method isn't really a factoring method. You'll see when we get there. But it's 4 different ways that we could end up breaking down a function that's a quadratic that a is not 1 into 2 binomials. Okay? The first method, which if you know how to do it properly, is the quickest and best method, but for some people it could be the hardest method because they just don't have the mental math skills to be able to guess the correct numbers, okay? But this is the best method for some people because really it just is the quickest method. So you open up 2 binomials, and you just start guessing at what the numbers would be inside it. Now, the first number in each is going to be pretty easy here because we need to know 2 things that will multiply to give us 5x squared. And that's obviously going to be 5x and x. So here and here, we need 2 numbers that are multiply to 12. So let's just start taking some guesses. And I'm going to guess one wrong on purpose here first. Plus 2 times negative 6. So how do I know that's wrong? Because if we were to multiply these, we get negative 30. Multiply these, we get 2, and negative 30 plus 2 is not 11. Okay? So what if we switch these numbers? All right, let's make it 6 and negative 2. All right, so let's try this one now. That would be negative 10 and 6. There's no way that's going to give us 11. So we just start taking some more guesses here. How about plus 3 minus 4? So that's going to be negative 20 and plus 3. That's negative 17. So that's not going to work. How about plus 4 minus 3? So that's going to be negative 15 and positive 4. That is going to give us a negative 11, which is great news because we know we have the right number. All we got to do is flip these signs. And now we get 15 minus 4, which is 11. So we know this is going to be the correct factorization. Now this took us, 5 guesses here, and we got it right. So that's not ideal. We don't want to have to be guessing 5, 6, 7 times. Really, we want to be able to guess it in 2, maybe 3 guesses in order to be saying that this is the best method. But we got it by guess and check. So let's take a look at another method that we can come up with the same answer here. Method 2, we call bottoms up. So in bottoms up, what we're going to do here is we're going to take A and C and multiply them. And then we're going to rewrite our function as 1x squared plus bx. That doesn't change. But now we're going to change C to minus 60, whatever that new number is. All right, now we're going to factor this, which has a coefficient of 1, a leading coefficient of 1 there, which should be easier to do. So if we factor this, we know it's going to be x plus 15, x minus 4. We should be able to factor that with ease at this point. Then what we're going to do is we're going to take this 5 and divide both of these numbers by 5. Okay, so then we get x plus 3. This one does not reduce. So what we're going to do is we're going to bring this 5 up here, 5x minus 4. And hey, look at that. That's the same factoring that we got in our first one. 5x minus 4, x plus 3. 5x minus 4, x plus 3. So that does work. The third method is called grouping. So in grouping, again, you're going to do that same first step where a times c is negative 60. Okay, so now we're going to look for 2 numbers. Let's call them, I don't know, m and n. M and n that multiply to negative 60 and that add to 11. All right, so start playing around with that, start taking some guesses at what those could be, and we should come up with the fact that m is 15 and n is negative 4, or they could be switched. It doesn't matter which one's which. All right, so I'm going to rewrite f with this middle term here broken up into 2 terms. So I'm going to rewrite f as 5x squared plus 15x minus 4x minus 12. So the 15 and the 4 coming from here. All right, then we're going to factor by grouping. So we're going to group these together and these together. Okay, so factor by GCF, we get a 5x. What's left is x plus 3. In the second part, factor out the negative 4, and we're left with x plus 3. So then our factored form is going to be 5x minus 4 times x plus 3. And once again, it's the same that we got for the first 2 times through. All right, so I said in the beginning of the video 3 to 4 different methods. Those are the 3 methods of factoring. There is a 4th method that's not really a method of factoring. It's a method of solving called the quadratic formula. That's why I put a question mark here, because it's not really a method of factoring. But we could use it to factor indeed. Okay, so what if we did the quadratic formula here, right? So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if we just simplified that, so negative 11 plus or minus the square root of 121 plus 240 over 10. Keep simplifying. Negative 11 plus or minus the square root of 361 over 10. Negative 11 plus or minus 19 over 10. All right, so that's going to give us x equals negative 11 plus 19 over 10 and negative 11 minus 19 over 10, which can be simplified down to 8 over 10 and negative 30 over 10, which can be simplified down to 4/5 and negative 3. All right, so how is that going to help us? Well, if we know the zero product property, if these were going to be our 2 zeros, then we would know that 5x minus 4 must equal 0 and x plus 3 must equal 0. So therefore, f of x must factor to 5x minus 4 times x plus 3, which is the same factor we got 3 times in our first 3 methods. Okay, this 4th method, the quadratic formula, is by far the worst method to do. Okay, but if we know our quadratic formula, it'll always work. If we forget the first 3 methods, okay, this method will always work for any quadratic as well, as long as it factors. Okay, if it doesn't factor, the quadratic formula will still get us answers if we were setting it equal to 0, but obviously it's not going to factor nicely like this. Okay, so when we do this factoring in class here, you can use any method that you prefer. Okay, obviously, whatever method works best for you is great. I prefer the guess and check method, but it's not what I prefer, it's about what you prefer. All right, thanks again, as always, for watching this video today, and we'll see you again soon.